110, his role was switched from standby to active, and his role was switched from active to standby. Now I can use this transport to still get to my network. But all VRRP is going to give you is the router redundancy. So that's where this network connection comes in between the pair. So if I have a network connection between the pair, and two lines are shown here because I could use two network connections, gig 02 and gig 03, or I could use one interface but yet set up sub-interfaces. Either way, I've got two paths between this pair of routers, and they both agree upon IP addresses and such as that. So now, by R52 extending a tunnel interface to R51 with regard to the internet network, what happens now is if I lose connectivity here, then the traffic will go across this tunnel interface to this router and then across the internet to wherever I have to go to. Well, likewise, we do the same thing with the other path. We use the second interface to extend a tunnel interface to R52. So now if we lose this network connection, now we can go across that tunnel interface and hop out MPLS and go wherever I need to. So this is referred to as TLOC extensions. So you may find a requirement for that, you may not. This is not a requirement for TLOC extensions because we already have a pair of routers and each router has dual or redundant connections to each of two transports. The connection we have down here, we have a pair of routers, but each router only connects to one transport. So what happens now is this router is going to see, obviously, the MPLS transport, but he will also see the internet transport. Well, R52 will be able to see the internet transport, but because of TLOC extensions, he will also see the MPLS transport. So now, this gives you the ability to have connectivity on each router to a pair of different transports by not requiring you to buy multiple circuits. So it has its advantages, and certainly if you have an environment such as that, TLOC extensions is wonderful. Now remember in the lab, and this will be on Thursday, when we talk about SDWAN features, the one feature that we have a lab exercise on Thursday is TLOC extensions. So you'll get the opportunity to configure that. So in the example of site 1 and site 2, we have a pair of routers, and both routers would have the same site ID, site 2, site 1. Now, this is a unique numeric value that you identify. I would really suggest that you put forth a little bit of effort in planning what you want your site IDs to be. The only requirement is that every site be identified uniquely with a site identifier, a numeric site ID. So you could just say site 1, site 2, site 3, site 4, site 5, and call it a day. But where these site identifiers are used is much later on in class when we start talking about policies. When you define a policy, you want to apply that policy to a collection of routers. And if you want to apply those policy to a collection of routers, for, say, for example, in the Western region, but not the Eastern region, then come up with the range of site identifiers for Western region and a different list of site identifiers in Eastern region. Now, you don't have to do that. You could just say, hey, my routers, my sites in Western region are sites 1 and 7 and 37 and 52 and 123 and 1,763,512. Those could be the site IDs for the routers in the Western region. So now when I want to apply a policy to those locations, I've got to identify those site IDs. But what might be better is to say, hey, all of those routers in Western region, they're going to be site IDs 100 through 200. So now, instead of specifying that in your site list, you just say 100 through 200. And now all the routers that live in those site identifiers, they will adapt the policy that's defined by the parameters rather that's defined by your policy. So come up with a strategy in these site identifiers. The number can be any number you want it to be, from 1 to 4 billion. Pick any number in between that you like, but every site has to be unique. Well, every router at those sites have to have a unique system IP address. So even though both of those routers are site one, this might be the system IP for router one, and that'll be the system IP for router two, system IPs, and so on. So every system IP address has to be unique per router. And then finally, the TLOCs. So we have two TLOCs on this router, we have two TLOCs on that router, even though we have one system IP address on each router, and they're both associated to the same ID, site IP identifier. So you see, a TLOC is a way for us to define our network point of attachment. So this router connects to the MPLS transport, therefore the color might be MPLS. This router connects to the internet transport, but because I can't use internet as an identifier because of security issues, I might call that public one, or I might call that private one, or I might call it blue. Again, you to come up with a naming convention for all these colors. Now the controllers themselves, as I said earlier in the class, they can be either on-prem, all of them, or they can be hosted. Now, if they're hosted, that means that you have a managed service for those. Now, hosted could also mean that you're subscribing for applications that's being offered to you in the cloud. So Microsoft Azure or Amazon AWS may be hosting those servers for you as a managed service. So it's kind of up to you. Now we can support a mixture of both V-Edge routers and C-Edge routers. So if you want to have a combination of both of those, a mixture, then the controllers need to be running at least version 18.3 code, and the V-Edge routers, to be able to understand that C-Edges even exist, are 17.2.1. So you got some minimum requirements if you want to have, a mixture of both V-Edge and C-Edge routers in your production environment. Now we got 7 different ways for us to identify our transport interfaces. One might be not very indicative of SD-WAN, but you might have an SD-WAN router connecting to either internet or MPLS. In other words, one of 2 different colors. You could choose to do that. Or you could have one router only connecting to each of 2 transports. Well, here you got a single point of failure for the router, and you got a single point of failure for the transport. But down here, we have transport redundancy, but we still have a single point of failure for our routers. So 2 different choices to begin with. And again, it really depends what your solution is going to entail. But if you want to have transport and router redundancy, then you would choose a pair of routers at the same location and have connectivity to each of 2 transports on both of the routers. So this gives you both router redundancy and transport redundancy. And here's that example of TLOC extensions once again. So this router is only connected to the internet. This router is only connected to MPLS. So if I lose this connectivity, traffic coming into this router can go across this path and get to MPLS and go wherever it needs to go. But if we lose connectivity here, traffic destined here can take the path across internet to get to the same destination. So that's TLOC extensions. It's when you have a pair of routers and each router is connecting to a single transport. But yet, you want visibility of both of those transports on both routers. So it saves you money, saves you time. I buy 2 transports instead of 4, right? Now this can be either a layer 2 or a layer 3 TLOC extension though. You may also have a requirement that based upon a prior or a connection you have in place right now, that you've got to use a legacy router because you're peering with a service provider router. Maybe you're using BGP there. So that too is also supported if you need to do that. So we can bring in a traditional customer edge router into the mix as well. So different types of connectivity options. One, of course, is a mesh topology. Each router is connecting to each a pair of transports. It could be meshed with a switch, right? They go through a layer 2 switch for the connectivity, so both layer 2, layer 3 be supported there. Now, as far as TLOC extensions are concerned, TLOC extensions over layer 3, as it says there, is new. This is only supported on C-Edge routers. But TLOC extensions over layer 2 is supported over or is supported using either V-Edge or C-Edge routers. But over layer 3 would be supported by C-Edges. Now that implies that if this interface here is subnet A and this interface here is subnet B, there has to be some layer 3 functionality to route between those interfaces. So that's all that's what's meant by TLOC extensions using layer 3. And finally, our routers. Our routers can be on-prem, they could be hosted. If they're hosted, that means they're out there in AWS or Microsoft Azure. And in addition, it could be physical routers, it could be virtual routers. Kind of depends what it is that you're looking for. But in the hosted cloud, notice that physical servers is not even listed here, right? Doesn't exist. So in the cloud, they only support virtual machines. So these will be cloud-based routers. Now, these cloud-based routers, they, from the perspective of what they do, how they perform, from vManage's perspective, they're no different. Now, as far as maybe a definition of SD-WAN, it's referred to as SEN, or Secure Extensible Network. We have separated the data plane from the control plane. The data plane, again, is down here with IPsec tunnels between your WAN edge routers, and our control plane is across those SD-WAN virtual fabric for connectivity to our controllers. Not just the vSmart controllers, but also to the vManage controllers as well. So vManage has to know about all of the routers and all of the vSmart controllers. And even though it's not really shown here, he also has a DTLS connection to vBond also. Now these DTLS connections, we call them secure control plane, but it's either an authenticated encrypted DTLS connection or authenticated encrypted TLS connection, one or the other. And if you're subscribing for a partner managed service, that's certainly available right now, then there is a top level ZTP server or top level plug and play server that's in the cloud that is being managed by either whoever the managed service people happen to be. No longer Viptela, but whoever the partner managed service folks happen to be. So the top level ZTP server up here, or the plug and play connect portal, your partner manager is adding new routers that you buy to the ZTP server here. When they're added here, it communicates that information down to your enterprise vBond controller. That's, again, if it's a managed service. Now, when you buy that router at a new, and you ship that router to a new branch location, that router then calls home. Now, the requirement for this router, though, is this. This router has an IP address on its SD-WAN side. This has to be a DHCP client-enabled interface. If you have a requirement within your production network that your WAN edge routers have to have static IP addresses, then you won't be able to subscribe for a managed service. They require DHCP. And subsequently, to resolve, remember, this is going to be able to resolve ztp.viptela.com into ztp.yourorganization.com. Then this request would go to the vBond controller, where the vBond controller already has this whitelist. Again, every router, every controller that you have in your production network is added to this vBond controller. So now when this guy calls home, he's in essence, number one, trying to be authenticated. The authentication is successful only if he's whitelisted in the vBond controller. Now, if he's there, other checks are also performed as well. For example, are both of these guys going to be in the same organizational ID as what's in vBond? And if the authentication is successful, then and only then would there be a DTLS connection or TLS set up between the vBond controller and this new WAN edge router. That's for a singular reason. The V1 controller then will update the WAN edge router with a list of his vSmart controllers and vManage controllers. Then that DTLS connection is torn down, and then across your transports, he will establish connectivity then to the controllers, where once again he's whitelisted. Now, the whitelisting authentication here should be successful because the whitelist that exists within these controllers, it came from VBond in the first place. So anytime a new router is added here, VBond automatically updates those routers there. Now the process that I'm walking you guys through is truly if you subscribe for a managed service. Now, as far as AWS is concerned, this kind of shows you what their implementation looks like. AWS has a vManage controller both in Oregon and also in Virginia. The AWS data center in Virginia has your primary vManage controller, and the backup image vManage controller exists in Oregon. They each have a collection of vSmart controllers, and they each house their own vBond controllers as well. Now remember, all of the vManage, all of these devices are required to have DTLS connections between them. The only one that does not have a permanent DTLS connection established between them happens to be the connection between the vBond controllers. So anytime new devices are added to this vBond, they have to also be added to that vBond as well. So it's not an update that's automatically performed between the vBonds. Across the rest of the, say for example, the vSmart controllers, then that is automatic, but not vBond to vBond. Yes, sir.
Yeah, hey, it's Frank. Is that by design that they purposely left that out, that syncing between them, or is there some feature there, some reason they did that? Seems pretty basic, like.
I don't know if it was something that was intentionally left out or somebody forgot about it, but that's just the way it works today. There is no DTLS connection between them. Even if you had a pair of vManage controllers, there's no DTLS connection between them either, but there is a messaging path that is set up between them on dedicated interfaces on both of the routers. So it's not a DTLS connection, but certainly the two vManage controllers within the same cluster, they certainly do know about each other. But between vBonds, that's not the case. So, I don't know, and I really don't know why that is the way it is, other than me just telling you that's how it's done. Now, if you have a managed service, this is completely outside of your control anyway. And if you are not using managed services, but managing all these controllers in-house, you may have just a single vBond controller. Or you may choose to have a pair, one in data center 1 and another in data center 2. So you just need to know going into this, without being blindsided, that any whitelist configured on vBond 1, you got to replicate that yourself to vBond 2. And again, the idea there is these WAN edge routers that's down here, they're going to communicate to a vBond controller probably by a DNS name. So if this guy does not respond, they automatically go to this guy. So you see, they both have to both have their own configurations. Their database is synchronized, I guess is the best way to put that. And it's not done automatically. So I wish I could answer your question was that something that was an oversight or something that somebody much higher up than we did in design decided that's not a requirement? I don't know the answer to that. All I can do as your instructor is just say it's not there. And if you have more than one vBond controller, then replication between them is manual. It's not automated.
Question on the DHCP required for the hosted solution. Is that only for the initial configuration with the vBond? Once it's authenticated through the vBond, can that interface then be changed to static?
Well, once you change the IP address on that outside interface, then now communications between the rest of the controllers and that router is going to be affected as well. So typically, no.
Okay.
You've got to decide, am I going to use DHCP assigned addresses or not? Now, the reality here is, if you're not using managed services, who cares, right?
Right.
Because you're not calling home to VBON anyway.
Gotcha.
I should say, who cares? It's just, it's not a requirement if you're not using managed services. All right, so your WAN edge routers. Now, first off, we'll talk about the vEdge series devices. We'll start with the vEdge 100. Now, the first thing that I want to talk about with these vEdge 100 series routers is this first bullet item here. They support 250 IPsec tunnels. Now, IPsec tunnels, what we're talking about there is the data plane. The IPsec tunnels from router to router. These have nothing to do with the DTLS connections from the routers to the controllers. So that doesn't even take into account. So all three of them, the 100, 100M, 100MW, they all support 250 IPsec tunnels maximum. So it kind of gives you an idea of the kind of environment that one of these routers might be deployed in. So let's talk for just a moment about full mesh. So if one of these routers supports 250 IPsec tunnels, let's start with that number, 250. So if I were going to design my network to go full mesh, how many sites could I go full mesh with if I were using the Edge 100 series routers? So first thing is, how many transports do you have? So if you have 2 transports, MPLS and internet, you got to divide that number by 2 because you're going to set up an IPsec tunnel to each router across both transports. So now you've got 125. So 125 sites you could go full mesh with using vEdge 100s if you had a single router at each location. But a lot of your sites, if not all of your sites, you're going to have 2 routers, dual routers at your locations. Now, if you do that, divide that number by 2, because each router is going to use both transports to get to every other router. So now you're looking at roughly 62 sites. So if you dealt with all vEdge 100 series routers, you could go full mesh to only 62 locations if you had dual transports and 2 routers at each site. And your goal was to go full mesh. So you see, it's kind of a low end kind of a deployment. Now, remember earlier I was talking about a customer of mine that had 638 locations. They used all vEdge 100 routers at each one of their convenience stores. So how could they go from 638 sites and still have connectivity? And the answer is they chose hub and spoke. They did not go full mesh. So the reality is they could have 638 sites or 6,038 sites, because if I go hub and spoke, here's your router down here communicating to maybe a pair of routers in the data center. And I have 2 transports. I've got a connection here, and I've got a connection there, and I got a connection here, and I have a connection there. So even though I might have 6,000 sites, I'm only going to have 4 IPsec tunnels from each one of my respective routers communicating to the data center if I had a hub and spoke topology. Now that's only half of the equation though, you guys. This is from the branch locations. These are from those convenience stores. But they're communicating over an IPsec tunnel to another router. These are the pair of routers that I have in my data center. Now, even though I'm hub and spoke, these out here, those are my spokes. The hub is the data center. So if I happen to have 6,000 locations, then this router here has to connect to 6,000 locations times 2. So he's going to have the capability to have 12,000 IPsec tunnels to have connectivity from his router to all the other locations across both transports. So you see, this does have a maximum growth. Now, the one advantage for having multiple model routers is the number of IPsec tunnels that they support differs, right? So VEdge 1000 supports 1500, and you can do the same kind of math there. 1500 IPsec tunnels divided by 2 transports is 750. 750 divided by a pair of routers at each location, 375 sites. So I could have full mesh between 375 sites with VEdge 1000s at every location. If I had 2 routers at every location and I had 2 transports reachable to each location, I can only go full mesh to 375 sites. Oh, but I've got 650 sites. Well, guess what? Can't use that if you're going to go full mesh. So VEdge 2000 or the VEdge 5000 becomes your other choice there. Now these are only your VEdge devices. Now all of the VEdges, the 100s, the 1000s, the 2000s, and the 5000s, they all come from the factory with a tamper-proof module, and that's what TPM stands for. The other differences, though, between all of them is how many physical interfaces you have, whether or not they support, cellular connectivity or not, power supplies. They all support security and QoS, and the other requirements will be based upon the licensing that you've subscribed. So, but this kind of gives you your limitations as to why you might choose one router to another. I've had customers that put in VEdge 100 series routers at 650 sites, but yet at the headquarters or at the data center, they chose for VEdge 2000s because that supported 6,000 IPsec tunnels. And they wanted to do that so if they needed to grow more stores, they'd have the growth already factored in the hub part of the network. So that's your VEdge 100, 1000, 2000, and 5000 series routers. In addition, there's also your ASR and ISR series routers as well, and we call those C-Edge routers. Now, something that I found out recently, which is different than it used to be, again, it's evolution. The way it used to be is when you purchased an ISR and ASR router, 1000, 4000 series, or whatever it might be from Cisco, it got shipped to you with the iOS XE software installed on it. Now, an ISR and ASR router that has the iOS XE software running on it, that is just a classic data center or a campus router. It is not an SD-WAN router. So what you have to do when you receive those routers is you've got to migrate them to the Viptela software. And there is an absolute series of steps that you must follow to migrate an iOS-based XE router to make it a C-Edge router. So a C-Edge router means that it's already running that Viptela software. The way it works now is when you buy your routers from Cisco's website, it can be shipped from Cisco with the appropriate Viptela software already installed on it. So you don't have to do that migration strategy. But still, you may have a stockpile of ISR or ASR series router in your own warehouse that you're deploying. And if you bought those some time ago, they probably all have the Cisco iOS XE software running on them. So you have to follow the process of how do I migrate this from iOS to Viptela software. And there's, again, like I said, there's an absolute step-by-step process you got to follow. And it is sometimes kind of painstaking, I have to admit. But just like on the VEdge side, we have different products because we've got different capabilities we're trying to use. So you may have ISR 1000s or ISR 4000s deployed to your branch locations, but then you may have ASR 1000 series deployed in your data center. And you've got this in a hub and spoke topology. It all kind of depends. We've got some products on the C-Edge side as well that are virtual routers, your ISR virtual routers, and that's the ENCS 5100 and 5400 series. Again, differences primarily between those two would be your throughput. So not earth-shattering here, but in a feature comparison here, you've got your ISR 1000s in this column here, your ISR 4Ks in this column here, and so forth. Notice that on the last one, it says EIGRP is not supported in any one of those, and that is no longer true. The no should be a yes now, and it became supported as of version 19.1. So as long as you've got version 19.1 code running in your C-Edge routers, then you now also support EIGRP. However, EIGRP is still not supported on the V-Edge product line. It's only supported on your C-Edge families. So this kind of shows you what is and what's not supported in these guys. So T1 interfaces not supported on these devices, and your XAA or SDSL types of interfaces are not supported on these, and also your 4G LTE is not supported on your ASR 1000s. Other than that, it's pretty consistent across the board. And in terms of topology, kind of a wasted slide here, but it's included primarily so that you'll know on your C-Edge side that deep packet inspection is supported on your C-Edge family of devices, but it uses INBAR to do the traffic classification. So instead of deep packet inspection. So INBAR is on the C-Edges, what deep packet inspection or DPI happens to be on your V-Edges. Both V-Edges and C-Edges, as I alluded to earlier, all support up to an 8-class model. And that is also 8 Qs, Q0 through Q7. And in case you've never seen pretty pictures, well, there you go. That's what the C-Edge platforms would look like. Scalability. Remember, we said that your V-Edge 100s, the V-Edge 100 series supported 250 tunnels. Your V-Edge 1000s supported 1500, and then you get to the 2000s and the 5000s, and they support 6,000 tunnels. Well, we've got the same functionality or similarities here on your C-Edge routers. Now here it's titled BFD tunnels. The term BFD and IPsec are two terms that are interchangeable. So therefore, when you see the terminology BFD, which is bidirectional forwarding and detection, BFD is for the health, it's monitoring the health and or the liveliness of the transport. So the transport is across IPsec tunnels. In other words, we're talking about the data plane. What we're using to forward user data from site A to the data center, or forwarding a voice over IP phone call from site to site. That's the data plane. So again, as you go down this list here, again, these two devices are somewhat, in terms of throughput, about the same as your V-Edge 2000 and your V-Edge 5000s. Now, this is not a complete list either. New products were introduced after the printing of this documentation a couple of years ago that have been added to the list. So anytime you're trying to find out which is the appropriate device to use, certainly always consult your design practices documentation and the release notes for the router that you're trying to roll out. And your families of routers, 4200s, 4331s, 4351s, memory, default flash, management interface. The console for the most part is typically RJ45, but as you can certainly see, there's also on the last three router platforms, the support for micro USB type of connectors as well. So kind of a comparison page between your ISRs. Not every module though is supported across every router either. So again, this is just letting you know that the supported modules may not and likely won't be interchangeable or connectivity exactly between the same model router. So again, check the release notes for the routers that you're planning on rolling out. Now this, for the most part, is dedicated to V-Edge routers, but pretty much the same thing we've already talked about. So on your V edges, how many IPsec tunnels are indeed supported? That's shown there. Rule of thumb, for every 2,700 V-edge routers, you need a vSmart, a vBond, and a vManage. Anything higher than that, start increasing your vBonds and your vSmarts. But regardless of that, you want redundancy with vSmart and vManage anyway. So you may not stick to that 2,700 V-edges in the first place. You may start off with 2 vSmart controllers and then maybe increase it from there. Give yourself redundancy, because you don't want to have one vSmart controller, because now you truly do have a single point of failure for your control plane if you lose that controller. And same thing down here for the data plane functionality, your throughput for each one of those. And the only topic that's new on this page is how many routes can be in the local routing table of each one of those routers. So certainly, by virtue of the fact that you've got a V-Edge 100, that's the low-end routers. So it's not going to be able to handle as many routes as your V-Edge 2000s and 5000s. And I mentioned VPNs already. Again, VPNs, pretend you heard the term VRF. And there's a total of 64 that are supported on your WAN edge routers. That includes VPN 0, and that also includes VPN 512. So on the service side, on the site local side, VPNs 1 through 511 are the values that you can choose from. But how many VPNs vSmart can handle? No hard limit to that. Alrighty, so a very, very long and I hope informative first module for you guys. That you guys get more of an idea of what the heck is really meant by SD-WAN. So now, this module here, I assure you, is going to go a little bit faster than the prior module, because we're getting closer and closer to the middle of the afternoon already here. But this should go pretty quickly, because we're going to talk about how we deploy all of these controllers, and then subsequently all of the routers as well. So in terms of installation and deployment, first and foremost, in your student documentation, it makes a reference to this URL. I just want to give you a replacement for that. So Viptilla does not exist anymore. So where you go to instead, and I would create a link to this in your favorites in your browsers, is go to SDWAN-docs.cisco.com. Just create a link in your browser, make it a favorite, because here, if you want to do a search, for example, on Viptilla overlay network bring up, just type that in when you get to that page, and it'll give you the same information that you see here as well. So again, it's just a replacement URL instead of anything Viptilla. Just go to sdwan-docs.cisco.com. That is going to be your repository for a wealth of information. You want to figure out how TLOC extensions works? Go to SDWAN-docs. You want to read more about what is meant by transport, what's meant by data plane? SDWAN-docs. That's the best place to go to. And we're talking about deploying these controllers. So you first have to have download rights on Cisco.com. So you go to Cisco's website, and you download the OVA for vManage. You're going to do the same thing for vSmart, same thing for vBond, but we got to start with one controller, so we're starting with vManage first. Before you've got a functional SD-WAN though, before you've got a functional control plane, all three have to be done, right? Now you might do this once for vManage and twice for vSmarts and once or twice for vBond, but these are all going to be virtual machines. So you're going to install these OVAs in whatever your virtualized environment might be. Could be vSphere, if you're going, you've got vManage or VMware running, or vCenter, or whatever your virtualized environment might be. So you go into your virtualized environment, log in your virtualized environment, go to File, Deploy OVA Template, which you have already downloaded from Cisco's website. This one is going to be vManage. Go to the next page. The next page is point to the location of where that OVA file exists, which will be on your local computer. Verify your OVA details, which should be already pre-populated for you. Give your OVA template a name. Since we're deploying vManage, that'd be a good naming convention to use. And make sure that you've got enough disk capacity. The default is 196.7 gig. And so not a whole lot of reasons that I'm aware of that you need to make that any larger. But certainly a larger enterprise deployment might consider making that disk capacity a bit larger, a bit bigger. Select the destination for your VM and then click on finish. So again, if you've ever installed any Linux operating system or even Microsoft as a virtual machine in vCenter or VMware, it's no different. You're doing the same thing. So you click on finish. Create a new virtual disk now for vManage database. It needs to be at least 100 gig capacity. Now it says at least 100 gig. I don't have any best practices for you from one enterprise to another, other than make sure it's at least 100 gig. And you're going to make sure that IDE happens to be the storage type that you're using. Again, these are the screenshots you'll see when you click on next and next and next. Finally, you got to create your interfaces. You got to add a network interface card for the virtual machine for managed purposes. And like I said earlier, if you're going to have a vManage cluster, you add an additional NIC for the message bus that's going to be used for communications between the two vManage controllers in your cluster. So you got your network interface cards added. So the next step is it needs to now be powered up. So you click on the power on button here. Launch the VM console. So wait for it. From the time you go from here to here, an hour could go by, right? Because it's got to be built. So you log in. You're going to log in using the default credentials of admin and admin. And that, by the way, is what we also have in our labs. We've not customized that. Select the hard drive that is your 100 gig or larger. And it's going to prompt you with, do you want to format that hard disk? And of course, you have to say yes. When you say yes, then the virtual machine is going to reboot, format the drive, and then build vManage database, vManage in the virtual machine. So now you're going to wait for a period of time for all that process to finish. So once it finishes, you're going to come back over here, and you're going to right-click on your device and say, log into the console. Or you might have a console option up here at the top, but you log into the console. And that's going to give you a screen that looks similar to this. It's going to give you the vManage. You can log in using admin and admin once again and go to configuration mode. Now, in configuration mode, this is what you need to do to get the minimum requirements so that this box can act as a vManage controller. So you go to VPN 0. Remember, VPN 0 and VPN 512 has specific purposes. Now, by default, VPN 0 is going to be associated to Ethernet 0. So the first thing we're going to do is disassociate VPN 0 to Ethernet 0 because we're going to use Ethernet 0 in VPN 512. So no interface Ethernet 0. Go to VPN 512 now and interface Ethernet 0, where you'll define an IP address and a mask. Yes, it's that format. And then make sure the interface is operational with a no shut command. And then for VPN 512, create a static default route pointing to your next hop router. That might be your ISP, or it might be your next hop router to get to your ISP, whatever it might be. Define your DNS server, and then commit and quit your configuration. So this is some of this is all defining just VPN 512. This is your management VPN. That's what VPN 512 is all about. So once you've got this part here configured, then you could open up a browser. As long as you've got IP reachability to this address, you can open up a browser that can reach that address and log into vManage via your browser. And again, the login credentials there also is admin and admin. Now, you're not going to do anything with it yet because it doesn't know anything yet about any of your other controllers or about any routers at this point. But just, can I log in? So once you've got your vManage controller configured for VPN 512, now we got to go back and set up VPN 0. So remember on the prior page in VPN 0, if I go back a page, All we did there was we removed Ethernet 0 from VPN 0. Now we're going to use Ethernet 1 for the physical connectivity for VPN 0. So interface Ethernet 1, here's your IP address, and followed by your mask. Do a no shut, and you're required to configure tunnel interfaces on your connections to your SD-WAN. So tunnel interface, allow service, at least for now, we'll just say all, and create a static default route pointing to your next hop router. And for VPN 0 also, define your DNS, and again, commit and quit. So now, so far, all we've got configured in vManage is VPN 0 and VPN 512. So VPN 0 is going to be for OMP, and VPN 512 is going to be for my out-of-band network management, so that I can open up a browser. I can open up an SSH connection and remotely be able to log into vManage. But we're not finished yet. Again, you're still logged into vCenter in the console of this device. We got to start making this device function more like a vManage controller. So you go back to configuration mode if you got out of it. Go to the system sublevel. Notice it says config system now, and define your host name, system IP address. Remember, every device has to have a system IP address. Every device has to have a site ID, a unique site ID, unless you have a pair of routers at the same site and they would share the same site ID. You have to configure an organizational name. Now, if the organizational name has a space in it, you've got to enclose the organization name in quotes. Define the IP address or the fully qualified name of VBON, and then commit and quit. Now, notice something here. I want to point this out. Hopefully it makes sense to you. If you were in a traditional router and you typed in a command, that command takes effect as soon as you hit the enter key, right? But notice here, hostname vmanage 01. Notice the prompt still stays vmanage. So changes to all of these SD-WAN devices, whether it be a controller or a WAN edge router, the changes do not take effect until after you commit, after you type in commit. So just kind of a heads up about that. Okay, so that's deploying vManage only. We got to do the same exact steps for vBond. We got to do the same exact steps for vManage, for vSmart controllers as well. So if you've got two vBond controllers, do this twice. If you've got two, the next page, if you've got two vSmart controllers, do that twice. So these are how many virtual machines you're going to be creating. So this series of steps, exactly the same as it was for vManage. Obviously, your IP addresses that you're going to use in VPN 0 and 512, though, those will be unique, again, to this particular device. Now, since we're defining vBond, this is the one command on the vBond controller that makes it a vBond controller. If I just type this in by itself without the local, then this is nothing more than a vEdge router. So a vBond controller is nothing more than a vEdge router with itself being defined as the vBond controller. So now, you've got vManage configured in your virtualized environment. You've got vBond configured, and repeat the exact same steps for vSmart. And again, configure system settings after that, just like we did in vBond, and every device will have the system, it's called the system block of parameters, but each one has to have their own defined parameters. So now, in my virtualized environment, I have one or more vManage controllers. I have one or more vBond controllers, and I've got one or more vSmart controllers. Now remember, by default, no device will trust each other. So even though they all exist in vManage or in your vCenter environment, they're still not going to trust each other. We've got to build that trust relationship. So this is exactly the same as if you were building your own lab, or whether or not you were installing your own controllers in your own production environment. The steps are exactly the same. Of course, more careful planning possibly to IP addresses and host naming conventions an enterprise network as opposed to a lab environment, but this is exactly the same. So since we just set up 3 different types of controllers, we want to make sure before going any farther that we have network reachability between them. So the first step would be to log into each one of the controllers, vManage, vBond, and vSmart, and look at the interfaces. Make sure the interfaces that we just configured are up and operational. Now the ones we haven't used yet, they can be down, but the ones that we've configured that should be up and operational, make sure that they have IP addresses and that the interface admin status and operational status is showing up. Well, that just says that the interfaces themselves are up. We've got to also make sure that we've got network reachability. So the next step is from one controller to the other, ping each other. Make sure that you've got reachability between those. So if you have all the interfaces up and you can ping from one device to the other, now you can start building those within vManage. Now notice that the command here, show interface, and it's piping it to tab. That's just kind of a best practices thing. You don't have to do show interface pipe to tab. You could just say show interface. But what happens is, based upon the size of your screen, that stuff just wraps around to the next line, and you kind of lose your formatting. So show interface tab puts it on your screen in a little bit better readable format so you can actually see the parameters. Okay, so now we got to log into vManage and start setting it up. vManage is going to be, again, from a provisioning perspective, all the devices have to be provisioned from vManage. And you're building your SD-WAN fabric right now. So within vManage, and this is what your home page would look like. Here's at the top, you've got these 3 lines there. That basically either expands this or it collapses that to the left. If it collapses it to the left, the only thing you're going to see is that. So none of this writing will actually show up unless you click it again and expand it to the right. So go to the Administration tab. Under Administration, scroll down to your Settings. Under Settings, set your organizational name. It says not configured now. Set your organizational name to match what you just configured in the CLI in vCenter. Edit or configure the IP address of your vBond controller. So here's your vBond controller. We'll talk about this port number a little bit later on. But 12346. If you're using DTLS, just so happens that UDP port 12346 happens to be the default base port number. And so that's what you'd specify there. Not a lot of reasons to change the default port number on controllers unless you have a pair of controllers at the same location and they're both behind one NAT device. And then we'll talk about port offsets and things like that later on. So port 12346 happens to be the base port number for DTLS. And if you were using TLS, your base port number, which is going to be using TCP, is going to be port 23456. So what we're doing is setting up the requirements within the vManage controller. So we're going to Administration and Settings. And now, how do you want to sign your certificates? So semantic manual. Again, that would indicate you've got a semantic CA server. You're going to issue the certificate signing request and manually install that certificate. Or you have your own internal enterprise root certificate. Whatever procedure you use internally is the ones you would follow there. But if you just use semantic automated, which is recommended, you can use the device's self-signed certificates. And just so happens that vManage, as of version like 17.2.1, it does and can act as a CA server on its own right. So basically, you're having vManage controller sign your certificates for your devices. So this is the easiest way to kind of get it deployed. But ultimately, you make the decision within your own production environment whether you want to do semantic manual or use your own enterprise root CA or again use self-signed certificates. When you're done, click on proceed and that'll take you into the authorization page. Fill out the form you're going to have sent to Symantec. So what is your organization name? You must observe case sensitivity here. It's absolutely a case sensitive parameter. The VBON controller and the port number, whether or not you want to use email notifications or not. If you set enabled here and you specify this is going to be the administrator that you want emails to be sent to, then he's going to receive an email from the CA server when he receives a certificate signing request for every single one of your controllers. So if you issued a certificate signing request for once for vManage, once for vBond, and once for vSmart, he's going to receive 3 emails back saying that the CA server received those requests. And your challenge phrase, be kind of careful here. This challenge phrase, part of the certificate signing process, if you're going to be redoing certificates down the road, you're going to need to know where that challenge phrase is. It might be something as simple as Cisco or Viptilla or Frog or Cat, but you need to know that name. And I mentioned it even furthermore by saying if today you're subscribing for managed services, and then in a year from now, you're planning on assuming the role of in-house management for all of these, get that information from your managed service folks before you tell them that you don't want to use their services anymore. Otherwise, you'll be billed on time and materials to recover that. Anyway, this is going to be your request. Once you finish that, click on save. How long is the certificate going to be valid for? Again, decisions for that have to be made as well. So now, if I log in, I'm still logged into Call Manager. So before I went to administration and settings, now I'm still under the dashboard. So go down to certificates now. If I go to certificates, make sure you choose controllers. Don't choose the WAN edge list. Our SD-WAN doesn't even exist yet. We only have 1 controller in vManage out of 3 of them, and that's the vManage controller itself. So nothing would be here if you did click on it. So make sure you select controllers, and the only controller that should be listed here would be your vManage controller. And here is where you're going to go to the right-hand side where the three dots, your ellipses are located, and generate a certificate signing request for vManage. Now remember, you got 3 choices of who's going to be your CA server, right? So next step is we got to add vBond to vManage. So we got to add vSmart to vManage. So configuration, we got to go to controllers now. So configuration and devices, don't choose the WAN edge list, but rather choose controllers. Click on add a controller, and we're going to add a vBond controller. When you click on vBond, what is the vBond management IP address, username, password, and check the box that says generate a certificate signing request. Add it. Repeat the exact same process for vSmart. Back to configuration, devices, add a new device, controllers. This time it's going to be vSmart. ×1, ×2, ×3, depending upon how many vSmarts you have. And then vSmart management IP address, admin, password, the protocol you're using, DTLS. This is self-populated, unless you want to change that. And again, generate CSR. So we've done this 3 times for 3 different controllers in vManage only. So other than telling vManage about 3 different controllers and issuing certificate signing requests for all 3 of those, the only other thing we've done is we've added them, we've installed them in vCenter in our virtualized environment. So now let's see the status of those. We go back into vManage. We go to configuration, under configuration, go back to certificates again. And you got 3 devices that should be submitted for signing to the CA server. So under certificates, make sure you choose controllers. Again, nothing's going to be here underneath that. Here's your 3 controllers that you just added, and all 3 have the status of CSR submitted for signing. Now, because we chose the recommendation for how these certificates are going to be used, in other words, self-signed certificates, what happens is vManage automatically signs those certificates for us. There's nothing more to do. You just go log back in. Remember that prompt where we said that we wanted to use emails? Well, if we said yes to that, then the person's email address that we specified, he would be receiving these 3 emails indicating that that the CA server has received all 3 of those certificate signing requests. And now, again, because it's an automated process, you go to configuration in vManage, go to devices, choose controllers, and those same 3 controllers are there, but now notice the certificate status is installed. So now we have the beginning of the capability of our 3 controllers to be able to start trusting each other. But we're not finished yet. So, also under the controllers for certificates, you can also see that we've got expiration dates for each one of those, and it'll also show you the serial number for each one of those certificates as well. So now vManage knows about himself. He knows about vBond. He also knows about the vSmart controllers also. So our controllers now, the next series of steps is going to vary depending upon whether or not you have a managed service or whether or not it is an in-house managed resource. So for now, we just need to get all 3 of the controllers in vManage so they know about each other. Okay, stepping forward though, licensing. What is your SD-WAN fabric going to be allowed to do? So from a pricing perspective, and I kind of disagree with Cisco doing this, putting prices in student materials, because these prices are as of 2017. Prices are going to change. The contracting process changed even since this was printed out. And what price one customer pays may not necessarily reflect what another customer pays based upon different, commission levels and reductions in price. Anyway, one-time hardware, software for your WAN edge routers, you buy those, and you got an annual recurring software subscription for vManage and for your vSmart controller. So you see, anybody can download the OVAs from Cisco's website. Anybody can install them in their own virtualized environments. But what makes it legal is when you've paid for the license. Now, the license tiers, this is not correct anymore. What we're using anymore is we're using a DNA type of a subscription. So this is what it was up until, I don't know, 6-8 months ago. It was Plus, Pro, and Enterprise. And the reason there's 3 different tiers is, again, basic, or Plus rather, you've got routing supporting static routing only. So you couldn't even implement OSPF or BGP. In the Pro, it supported the BGP and the OSPF, also supported in Enterprise. The topology was hub and spoke was all supported in the Plus, but in addition to hub and spoke, full mesh, partial mesh, hybrid, and so on were supported in Pro and also Enterprise. And NAT split tunneling supported across the bell. Different types of policies that could be created. Again, supports local access lists, or it supports data policies only. But now we can also do control policies in the Pro and the Enterprise. SLA, 5 tuples, that's regardless, and deep packet inspection for visibility. And multicast was added to Pro and Enterprise, and vAnalytics was supported in Enterprise. But that's not the way it is in DNA. In DNA, for example, vAnalytics was added to the 2nd tier. And by the way, this was now referred to as basic. This is referred to as advantage. This is now referred to as premier. So I gave you a link here to go out and take a look at the different license levels. If you're involved in making purchasing decisions, obviously it's going to be dependent upon your licensing that you're paying for. And this kind of breaks it out for you as well. I just showed you the same thing on the prior page, but you know, Plus, Pro, and Enterprise, or Basic, Advantage, and Premier, really what's being used today. These slides eventually, sometime down the road, when Cisco updates this class, it'll be reflecting the DNA pricing or the DNA options and features instead of the Plus, the Pro, and the Enterprise. But now, that's what it is. But along with the licensing, there is also an entitlement that is based upon bandwidth as well, and it is additive bandwidth. So circuit 1 is 50 meg symmetric, so we got 50 meg up, and we got 50 meg down. The circuit 2 is 100 meg down, and it's got 20 meg up. And circuit 3 is 200 megabit down, and it is 50 megabit up. So the entitlement is aggregate, the higher bandwidth either up or down added for all of your circuits. So 50 meg plus 100 plus 100 equates to 350 megabyte license entitlement. So that's also part of your, the pricing. Now, this also shows that we have a pair of routers at a branch location, and they have TLOC extensions configured. So that bandwidth is probably a gigabit, right? A gigabit speed. So the TLOC extension bandwidth is not used, or not included rather, in your bandwidth entitlement. And nor should it be. Gosh, if it was, geez, talk about free money. Anyway, that's your license tiers. And your portfolio. So again, the 100s all the way up through the clouds, just kind of shows you price tags. I really wish that they would not do that, but there they are. And your pricing tiers based upon Plus and Pro licensing on this page for a 1 year, 3 year, 5 year plans. Again, based upon what your throughput capabilities are, those are shown. And again, a billing of materials here for the 100s, the 1000s, and the 2000s kind of gives you an example of prices. Again, all of that is subject to change, and this was all as of, back in 2017. So kind of old. So a little bit now on plug and play and ZTP. So ZTP and plug and play, zero touch provisioning and plug and play, provide, as it says, automatic provisioning using Cisco as a service that allows your WAN edge routers, both C edge and V edge routers, to join this overlay network automatically. And literally, you buy the router, it is shipped to the remote location, the installer at the remote location unboxes the router, plugs in the network cables, plugs in the power cables, and you're off and running. Done deal. So, but conceptually, the process is indeed the same. So you guys, let me close my door. I got people that are coming in. Someone's at the door, hon. My wife has some people coming over this afternoon. I have to keep them out of arm's reach. So ZTP and plug and play. The differences is for a plug and play mechanism, ZTP uses ztp.viptilla.com for the devices, the WAN edge routers to call home, whereas this is using the devicehelper.cisco.com for all devices going forward, whether they're C edge or V edge. So ZTP, not used going forward. Plug and play is going to be our mechanism. So it is not only used for ISR, ASR, ECS devices, but also for V edge routers as well. It is based upon the concept of zero trust. So vManage can sync with the plug and play server. That's that top level server. So on this side, it was called a ZTP server. At the top level, he communicates down to vBond. Now, the plug and play server is that equivalent server on the plug and play side. He communicates down to vBond as well. So you see, concepts pretty much the same thing. Content from the plug and play gets replicated to ZTP. Now, I even think that the terminology ZTP is also been changed now as well. But again, this is your managed service folks. They log into the Plug and Play Connect portal page where they add your information about your new router, and that information filters down until the point where it eventually gets installed on your VBON controller. Now, you basically plug your router into a new production environment, and he calls home, and it could be auto provisioned completely at that point. But regardless what you do to that box, he can still join the control plane. He may not have connectivity via the data plane yet, because he may not have his configuration, but he'll have connectivity to the control plane. Day zero, again, you're plugging the router in for the very first time in its life. So there is very little configuration on that router, certainly nothing to speak of with regard to SD-WAN. Or if you've done a software reset, it puts it back to the beginning as well. So you'll see that while you're trying to do this plug and play process, there will be occasions when the plug and play process will not be successful. If it is not successful initially, what they recommend that you do before shipping the router back to Cisco is stop the plug and play service and access the configuration terminal of the device. So in other words, you're going to type in plug and play service discovery stop. All of the routers, they are typically enabled for DHCP, a managed environment. And some of your routers, though, they also have switch port capabilities that VEdge routers never did have. But in any case, those would be hardware-based devices. And this walks you through the ZTP process, which is, if you remember me saying a moment ago, ZTP is no longer. Right? We're replacing the ZTP process with plug and play. Now I have this exact same page replicated later on in this module for plug and play. So to not waste your time on something that's not being used any farther, the only difference on the plug and play page that looks exactly like this is this part right here. So the router resolves ztp.viptilla.com if it's ZTP, but otherwise it's going to resolve device helper.cisco.com. And for the most part, everything else is exactly the same from this flowchart perspective. And we're going to analyze this page more in depth when we start talking about plug and play. So you got a zero-touch provisioning server. Again, you've got a VEdge router that you're trying to roll out. So the assumption is for that VEdge router that you've got DHCP enabled on that transport side, and you need to have DNS implemented, who your DNS server is, to resolve ztp.viptilla.com, which, by the way, is what you get from the factory. So you can't, if you're truly going to be using plug and play here, then that is part of the default configuration on the router when you get it from Cisco. So therefore, who is Viptilla.com? So you're going to have to make sure that your DNS server can resolve ztp.viptilla.com to ztp.yourorganization.com, whatever it's going to be. But again, this is part of the managed service. So assuming that you've got DHCP and DNS is workable, when this guy calls home, he's going to send a query to ztp.viptilla.com, which will be remapped to the top level ZTP server. He's going to redirect you to your corporate orchestrator, meaning to your enterprise VBON controller. Then the VEdge router first will set up a temporary connection to VBON, get the information about vSmart and vManage, tear that connection down, then establish connectivity to vSmart and vManage after that. Once he connects to vManage, he will download at least the initial configuration for vManage so that he can participate in the control plane. And if you've got vManage configured accordingly, then vManage can also upload or have the device down, have vManage upload the full configuration to that router, and it's a fully functional properly configured router in your production network. And from the time the router was shipped from Cisco until now, nobody logged into the router. So that's the whole process of ZTP. It's a managed service. So you don't have to worry about configuring vManage, configuring vBond, configuring vSmart, or logging into the plug and play connect portal page to get any of this to work. It's a managed service that you're paying for. Now, if you've got a cloud-based router, though, that you're deploying, whether it be in Amazon, AWS, Microsoft Azure, or in your own vCenter, since it's a cloud-based router, it's another way of saying that it's a virtual router. If it's not a physical router, guess what? It has no chassis. And if it has no chassis, it can have no chassis number. No chassis number, no serial number. How do you get vBond and vManage to know that this device even exists? So on those cloud-based routers, you've got to run this cloud init configuration file. Now what happens is, after running that file, a UUID for that device is generated, and that UUID is going to become the chassis number of this cloud-based router. Likewise, there's also an OTP, a one-time password generated as well. This is going to be the token that you'll have to use to validate the device. So in vManage. So for devices that are virtual devices, you've got to run the cloud init configuration file in order for us to generate what will become a chassis ID and a serial number, so this guy can be whitelisted. So everything else, though, from that point, okay, so goes exactly the same way. The router boots up using that cloud init configuration file. You're deploying it, and then he communicates to vBond, gets the information for vManage and vSmart from vBond. Then he sets up his connection to those two controllers, downloads at least his initial configuration from vManage, if not his full configuration, and then that cloud-based router now is fully configured, fully functional router in your production environment, even though it is cloud-based. So in ZTP, the initial steps are, after ordering, Cisco is going to generate the vEdge's chassis number for you. That all happens before it even leaves the factory. Now, if it's what you can do is you can download this vEdge list. That's the equivalent of the whitelist, but it's a .viptilla. It'll be some kind of a file name, like in ours, for example, it's an enter1.serial.viptilla. That's the name of the file. And in that file is a list of all the chassis IDs and all the serial numbers of all of our WAN edge devices, controllers and routers. So that's what they're talking about here. You can download that from, if you are the managed service folks, you generate that file in the plug and play connect portal page. And that's what gets installed in vManage. So once you've got that file, you can upload it to vManage, and that becomes, again, from vManage's perspective, the vEdge whitelist. Select one of the available vEdges and then attach a device template to that vEdge. Now, this could all be done while the router is en route. FedEx is shipping it to a remote location, so all of this can be done before the router even reaches the branch site where it's going to be installed. So you now know the chassis ID of that router. So under your configuration and templates, scroll down to the template that you already know you're going to attach to this router. Now the assumption here is these templates already exist. So assuming that the templates already exist, locate the template by name, scroll to the right-hand side, click the ellipses, and here's where you will go on attach devices. Notice the parameter below that, detached devices. So any given router can only be attached to one device template at a time. So if you've attached a device template to a router and you wanted to make some changes to the template that affects just the one route, guess what you can't do? You can't change those parameters on the device template you're using because 10 other routers are using that same template. So you can't make changes to it. So what you do instead is you would copy that device template using the copy parameter here. Copy the device template that you're using right now to another device template name. Edit that device template with the parameters you want to roll out to this 1 or 2 routers. Then look at your list of templates, find the template that your router is currently attached to, and click on detach. Once it's detached from that template, then you can come back to the list of templates, find your new template, and attach the router now to the new template. So that's how you could make changes to 1 or 2 or 3 routers when a single device template is associated to many more routers than that. So, but this is where you attach a device template to the router. Now, back a page here once again to look at my device templates. In any one device template, you're going to have a lot of parameters that need to be defined for a given device template based upon the feature richness that you're going to associate to routers that are using this particular device template. But one thing that cannot be configured in a template is anything that is specific to any one router, right? After all, the template says, hey, I want to reuse this over and over and over and over and over again. So any parameter that is device specific, for example, IP addresses on your interfaces connecting to your transports, interfaces on loopback, interfaces on your site local side, system IP addresses, site IDs, host names, those are all going to be referred to as device specific parameters. Those must be defined outside of the template itself, because that's going to be specific to any one device at a time. So when you click on attach device here, you're going to have to go and define what those device specific parameters are per router. So let's find the router to begin with here. Let's say it's this router. You got to know its chassis ID on a brand new router. So you find that router by its chassis ID and you slide it over to the right. When you slide it to the right, you click on attach. Now, something very important is happening here right now. Before you attach a device template to a router, it's going to be in what is referred to as CLI mode. Now, there are 2 modes that any one WAN edge router can participate in, either CLI mode or vManage mode. That's the only 2 modes that exist for these WAN edge routers. So when you attach a router to a device template, what you're doing is you are changing that router from CLI mode to vManage mode. Now, while that router is in vManage mode, you cannot make any local changes on the router via the CLI. It just simply will not allow you to, because it's centrally managed by vManage. So any modifications to this router now, in other words, anything that you have to go into configuration mode to do, you can't do it anymore on the router if it's in vManage mode. It has to be done from vManage by way of making a modification to the device template or making a modification to a template that's used by the device template, one or the other, but it has to be sourced by vManage. Now, likewise, on that prior page where we said detach the device from the device template, when you detach a router from the device template, it automatically puts it into CLI mode now, which means that now you can log into the router and you can make local changes on the router itself if you need to. So make sure you know the difference between CLI mode on a router and vManage mode. That'll be one of the first things you'll be asked to do in the lab. If your router right now happens to be in vManage mode, and it's going to kind of be a draw, it might be one or the other, based upon how it was left the last time the router was used. If it's already in vManage mode, remember the first lab is we want you to reset the router. Well, you can't log into config mode, make any changes if it's in vManage mode already. So you got to change it to CLI mode. And there's going to be two ways for you to do that. But this would be one way, and that is to detach a device from an existing device template. But anyway, we're saying we want to bring a router up. So we're getting a router in, getting it attached to a device template, and making this router a functional router in your production environment. So we're attaching some router from the left side to the right side, and we're clicking on attach. Now this should make sense to you. If the router that you're looking for is not here, then it probably means he's already attached some other device template. You can't attach him to this template because he's already attached to one. So that's just something to consider as you're going through this list. So let's attach that router, and now these are the device specific parameters for that router. Anything that's defined here is unique to this one router. Now, you're gonna get to this page here because in looking at your templates, we are going to edit the template that we just attached that router to. Clicking on edit will take you to this page so that you can fill in all of these device specific parameters. Click on update. Once you click on update, then you'll click on next here, and then it'll take you to a task view page that says, I'm attaching this device template with all of these parameters to this router. And so this becomes your task view page. So once it's completed, you should see a line here that says something like the device template was successfully attached to the devices. If you see that, how you interpret that is this device now is in vManage mode. So you cannot make any local changes to the router if you want to. So in this plug and play architecture here, we've got two different administrative type of tasks. One are tasks that you perform, and the other would be those that the installer performs. So assuming you've done your job on the ZTP server, if indeed it is a managed service, or you logged into the Plug and Play Connect portal page, and then you've installed the whitelist on your vManage controller, now all the installer has to do is wait for the router to arrive at that new branch location, plug in the network connection, plug in the power connections, plug it up. As soon as you power it on, he's going to download his configuration from vManage. It'll be a fully functional router now in your SD-WAN fabric. So the plug and play devices, not all of them support this cloud init configuration file, obviously, because this is a virtual router and this is a virtual router. So both of those support the cloud init configuration file, and the rest of them support plug and play only. So your plug and play workflow here, again, at manufacturing, a product ID and a serial number is created. You have to configure your own organizational name eventually, but that information gets sent to the Plug and Play Connect portal page. You're going to add to the Plug and Play Connect portal page, your information about a brand new router. Or this will be the folks that you're subscribing for managed services from. They'll log into the Plug and Play Connect portal page, and now we've got a chassis ID and a serial number associated to this brand new router. That gets synced with your smart account. Now in vManage, you've got to send that information now to vBond and to vSmart. So you log into vManage, and then you click on Send to Controllers. And that's going to allow that information now to populate inside your vManage controller. So managed services makes life a lot easier for you. All you've really got to be worried about in your production network are your routers, right? Now, the templates that your routers use, you'll have the ability to create your own templates there. You've got the ability to create your own policies and attach those to templates that your routers are going to be configured for. But from the controller perspective, that's all part of what you're paying for managed services for. Now, as you start looking at these WAN edge routers status in vManage, they could either have a status of staging or they could have a status of valid. So notice the difference between the two here. Control, OMP, and BFD are all up and operational if it says valid, but if it says staging, all it is you have no BFD sessions. Again, no BFD sessions. BFD is another way of saying your IPsec tunnels. So in other words, you have no data planning, right? No BFD sessions means you have no data planning. So is that expected? Well, right now, is this the only router that you have added to your network? Is this the first router? If it truly is the first router, then it's possible that there will be no other BFD sessions because I have no other routers to set up an IPsec tunnel to. So whether or not staging is an expected result or not, is it the first router? And so this is that same exact diagram that we saw earlier. And what the flow would be, earlier remember it said ZTP up here, right? And now this is my plug and play flow instead. So let's walk through plug and play. So you power up your brand new router, you plugged in the power cables, you plugged in the network cables, and you turned it on. Next step is the C-Edge router is expected to get an IP address from a DHCP server. Now remember, DHCP, when it issues a DHCP request, the client is expecting to get several responses back. He should get an IP address, he should get a network mask, he should get a default gateway, and he should get a DNS server. So those are all the responses I should get back by issuing the DNS request. So now remember, this guy is going to have to resolve devicehelper.cisco.com. So I need to know who my DNS server is. That's why DHCP is a very good thing, right? So now, once I get my IP address from the DHCP server, and I have those parameters as well, now he needs to resolve devicehelper.cisco.com, which he will. So now the C-Edge is going to connect, or authenticate rather, by the plug and play connect portal. This is only if you're using managed services. So he gets authenticated by plug and play. The plug and play now already knows that this brand new router belongs in your organization. So the plug and play connect portal, in other words, this is the equivalent of that top level ZTP server I was talking about, except for using plug and play now. He's going to provide your organizational name and your enterprise vBond controller information to your brand new router. Next step is he's going to now communicate with your enterprise vBond controller and perform a two-way authentication. I am who I say I am, and you are who you say you are. And again, I already know, the vBond controller already knows your organizational name. So that's also something that is verified in each direction as well. Making sure that some other device that is in somebody else's organization never shows up in yours. The next step, I need to communicate to vManage. And again, the same exact thing happens to vManage that we just did in vBond. Once I'm authenticated to vBond, or to vManage, excuse me, once I'm authenticated to vManage, that DTLS connection we talked about before comes up. Now, vManage now will communicate to the new WAN edge router what his system IP, site ID information is. In other words, his system level parameters. Here you go with your system level parameters. Now, at this point in time, he's still not a fully functional router yet. He knows that he's got DTLS connections now created to the vManage controller and to vBond. But he doesn't have everything that he needs to communicate. So he's going to go back to vBond again, get the information he needs to communicate not only to vManage, but also to the vSmart controllers. Now he will set up his connection to vManage and subsequently to vSmart. DTLS connections will be created to both of those, and then he will download his full configuration now by using a device template from vManage, and he becomes a fully functional router in your production environment now. And at that time, he joins the overlay fabric. He now sets up DTLS connections, he sets up IPsec tunnels to other WAN edge routers. And now this is a fully functional router in your production environment. So this is the flow that takes place with plug and play. It's a lot more streamlined, believe it or not, than it used to be with ZTP. And it's good because that is the default behavior that's taking place now for all routers, not just CEDGs. So this is the same page we saw earlier, just kind of blown up. But again, in the plug and play connect portal page, a brand new device has to be added by its chassis ID and serial number. And the plug and play portal page already has a list of all of your devices, your organizational information, and that's what's going to be communicated to your WAN edge router, your organizational name, your address of your vBond controller, what port number you should be using, and information about your root CA server. Again, certificates need to be exchanged as well, and we'll see that coming up a little bit later on. So if you have the entitlement for you to be able to log into Cisco's Plug and Play Connect portal page, this is what it looks like. If you have never seen this before, that tells me that either you guys haven't rolled out SD-WAN yet, or somebody else within the organization has the entitlement to do this. And furthermore, the other question to be asked to get an answer to is, are we using a managed service, or are we doing in-house internal management of our controllers? Because if you're doing internal management of your controllers, then you log into the Plug and Play Connect portal page, you log in the addresses or the information about your routers, and then you download the serial list from the Plug and Play Connect portal page, and you install it in vManage. If you're using a managed service, all that's done for you, right? Which is why you're paying, big bucks for that in the first place.
Hey, Roger, question.
Yeah.
So before we go on, regarding the traffic flows from when using the PMP, it's a requirement to have a one-to-one static net because there's inbound and outbound connectivity between vBond and the router?
Yes, that is always best practice, is that if vBond is NATed, that you use a one-to-one NAT, because your routers couldn't handle the address of vBond changing, and that could happen if it's NATed, right? So in other words, the address of your vBond and the port number that your vBond is using cannot change.
Well, I'm actually asking. So when you deploy the PMP, you're using a DHCP address on your CEdge, right? And if it's a private IP address, it needs to be added, of course, to go out to internet first, and then if for some reason the vBond has to communicate back on a new connection, it would need a static one-to-one NAT, correct?
That would be correct, yes. That would be correct. Bottom line is however you go about it, there has to be IP reachability, period. And so, and that IP reachability is something that has to be consistent. So the address and the port number being used for either UDP or DDP, TCP can't change. So if you are behind a NAT device, even if vBond requires that if it's behind a NAT device, that you have to use one-to-one NAT. And as far as your router is concerned, again, kind of the same thing there as well. If you're using NAT there, certainly it should be NATed with the one-to-one device as well. Sure.
Okay.
But I don't want to put you off because I know that there's still scenarios in your mind. There's a lot more to us getting our initial connections up that we've had the opportunity to talk about as of yet. There's a lot more coming, and we'll talk about that in module 3. Okay. So, okay. But for now, that is your connectivity options. The goal of the first 2 modules is really to give you an updated awareness of what is SD-WAN and what is meant by vBond, vManage, and vSmart. What is the control plane? What is the data plane? And if you've got those concepts rather solidified in your mind, then the module 1 and module 2 are accomplished, in my opinion. Certainly a lot more is going to be added to that when we start getting into module 3 and module 4, because we need to bring up the control plane on our routers. We need to bring up the data plane on our router. So how that actually works is going to be even more authentication that has to take place. So just to get a WAN edge router to the point where he can call home, that's really no farther along than that is what we wanted to accomplish in the first 2 modules today. We're going to be adding a lot more to that. So all of our controllers obviously have to be up and operational. SD-WAN as a virtual fabric cannot exist unless all of those controllers are indeed up and operational. So spin up your controllers. You have to plan on your network configuration because we have so many different components in each device that has to have unique and valid and reachable IP addresses. Add your controllers to vManage. We did that earlier in the material. Sign your certificates. We showed you that as well. As long as authentication between devices are complete, notice this is huge. Your control channels are brought up automatically as soon as those controllers are functional. Now, don't misread that. The control channels between the controllers are functional, not between the WAN edge routers and those controllers. That's going to come about when we get into module 3 tomorrow. Okay? But just between the controllers themselves. All right, you guys. Module 1 and module 2, as they say, is in the books right now. So let me give you guys, let's see, where are we here? We're about only 1:30 in the afternoon there and on the East Coast. So let's take about a 12-minute break. And I'll make sure that I'm going to give you guys a demo of Lab 0. And then the fortunate thing is the rest of today is going to be for you to go through Lab 0, Lab 1, Lab 2, and Lab 3.